Welcome back to our event on waste to energy plants. Now, if you have spent any time around the climate sphere in Brussels, you're sure to have come across the phrase climate neutrality. Europe has pledged to reach net zero emissions by mid-century. That means any emissions after that will need to be offset by another removal elsewhere in the economy. Carbon capture and storage technology could offer that type of removal. Our next debate looks at Europe's goal for climate neutrality and what role carbon capture could play in waste to energy in the future. To discuss this, I'm joined by Tamme, founder and managing director of Climate Principles, in the studio, and Jannicke Bjerkas, carbon capture and storage director at Fortum, Oslo Farm Online. Now, again, we will have our presentations and hopefully some time for questions afterwards. So first of all, Eve, let's start with your presentation. Can you tell us more about waste to energy and carbon capture and storage in European policy?
Thank you so much for the introduction, Kira. And it's a pleasure to be here to share my take on carbon capture and storage and how it can help to reduce the emissions from waste to energy sector. And as mentioned in the introduction, the background behind us is the climate neutrality target, and everything we're doing now should be with a view to how to achieve that. I had some slides, so maybe we'll start there. Exactly, beautiful. And I think we can already move on to the next one. So I'll just use this introduction to give a bit of a background on waste to energy and CCS and how the climate policy currently regulates all of that. So we have quite a bit of waste to energy plants in Europe, and I think you got quite a good overview already in the previous presentations on waste to energy as such. And currently, if you look at the EU's sectoral climate policies, then we have the EU emission trading system that covers 40% of emissions, and we have the effort sharing regulation that covers 60% of emissions. And currently, waste to energy falls under the effort sharing regulation and the part that this policy aims to do to achieve the climate targets. And of course, the recent Fit for 55 package is proposed to change this mix a bit because there will be a new emission trading system for buildings and transport that will take a good chunk of the effort sharing regulation emissions, let's say 2/3 of them, which means that what will be left under the effort sharing regulation is going to be a lot less, maybe around 20% of all emissions. There will be less to play around with. I wanted to, and maybe I should have started with a disclaimer that, obviously when we talk about waste incineration, and when I talk about it, I always have it in mind in the context of waste hierarchy, reuse, reduce, recycle. And but I saw that in the previous session you got an extensive overview on that, so everything I will say will be again against that background. And when we talk about carbon capture and storage, obviously this comes to play in the context of reducing emissions in this sector. Partly, hopefully the emissions from incineration will be reduced because we will be reusing more, we'll be recycling more. So that's one part. But we'll not be able to reuse and recycle everything, I think, for a long time. And residual emissions are there, residual waste is there, and hence the emissions from waste generation will be there. And one very obvious solution to that is to capture those emissions and transport and store them in geological in geological solutions where they will be stored for thousands of years. Now, this is very location specific, though, and it will not be a solution to every single waste to energy plant. So having access to that carbon CO2 transport and storage network is going to be crucial for those plants that are considering using carbon capture and storage as the emission reduction or carbon removal solution. So that is something to bear in mind, that the location matters, And the other part is also the size of the plants. On very small plants, it's going to be more difficult to find that business case to apply carbon capture and storage. If we move on to the next slide, then I'll talk a bit on what we could do to improve the policy frameworks. One big thing that the stakeholders have been asking for a really long time now is to have a carbon price on the waste to energy emissions. And this obviously would be also extremely helpful when we talk about waste to energy with carbon capture and storage, because having that carbon price good, it's not going to be the only solution that makes CCS happen on waste energy plants, but it can definitely play a very big role in incentivizing deploying these new technologies. And so one solution is to include waste energy under EU emission trading system. The current one, I'm not sure if these conversations are going on, but the other emission trading system for buildings and transports, there might also be a way to maybe include energy waste incineration with energy recovery under that, if the heat is used for commercial or residential buildings. So there are options out there, but it seems like we don't have a proposal yet on the table that specifically offers a solution. So we know that the co-decision process will be now ongoing with all these proposals under Fit for 55, and I think there's ample of opportunities to bring this topic up and try to make it happen. Another topic, very important, I understand hear more in the next session, is including waste energy in sustainable finance taxonomy. Again, I know why it's not there yet. There are some carbon capture and storage applications that are taxonomy compliant and already within the scope. Waste to energy is not one of them, and it's a bit difficult, but we need to have a lot of perseverance to make it happen, because it's going to be crucial to secure those funding opportunities. And talking about funding, I think that's one of the big discussions that we have when we talk about achieving climate neutrality eventually. I always try to highlight that the funding in Europe is happening on two levels. One is the national level, and the other is on the EU level. So if you talk about waste to energy, especially the countries that are that have high emissions from waste to energy sector, it's important to highlight that in their national decarbonization strategies, foreseeing funding for different solutions to reduce emissions, and again, waste to energy and carbon capture and storage on it are something that can reduce emissions in quite a few countries. And in the EU context, Innovation Fund is obviously an important source, and I think you'll hear a bit more on at least one of the projects that have applied and have made it to the second round in the next presentation. So yes, we'll need funding to make it happen as well. And I'll stop here.
Brilliant, thank you, Eve. And Jannicke, I think we can come online to you for your presentation. You have the floor.
Jannicke Bjerkas, I'm the CCS director in Fortum Oslo Varme. We are aiming to establish carbon capture and storage from our waste to energy plant in the city of Oslo. Next slide, please. Just briefly on our company. We are a district heating company where the main heat load is coming from our waste to energy plant. We're also providing district cooling and also utilizing heat from other sources where the excess heat would otherwise be lost. On the next slide, we can see a little bit more details about our specific projects. As I said, we're aiming to establish carbon capture, which, if everything works as we hope, we will be the world's first full-scale CCS project on a waste-to-energy plant. Our project is part of the Norwegian full-scale CCS project named Longship, after the Viking ships, where the goal is to establish a full and open value chain for carbon capture, transport, and permanent geological storage of the CO2 below the seabed in the North Sea. There are two capture projects in this CCS project, one from cement and then our project from waste to energy. Our goal is to establish 400,000, to capture 400,000 tons of CO2 every year, which will be about 90% of the total emissions from this plant. And the specific advantage with waste to energy, which several of the other speakers have touched upon, is that about 50% of the CO2 emitted from these plants are biological CO2, which means that this CO2 stems from biomass, biogenic waste, and is thus a part of the natural CO2 cycle. So when we capture and store this CO2, we are in effect removing CO2 from the atmosphere. And this will be an important technology to help reaching the European and the global climate goals. We have been working with this project since 2015, maturing through feasibility, concept, and FEED studies. And we've also had the project externally quality assured from the Norwegian state. Our project is also important because it demonstrates how we can solve the challenges of transporting the CO2 from the plant to port when the emission point is not actually situated at port. We will solve this transport by using emission-free trucks, preferably electric trucks, and the distance is about 10 kilometers. We have tested our technology very thoroughly. We chose amine technology, which is the most mature technology today. And the technology had been proven on capture from coal power, from gas power. The change with this project is that we are working to reduce emissions from industrial emission points that don't really have any other solutions for reducing emissions. And we decided to build and operate a pilot to test the technology on the industrial flue gas from waste to energy. We had very good results, tested for 9 months with this pilot, and we had very low emissions, high capture rate, and stable operations. So we are quite confident that this plant will work very well also at full scale. On the next slide, this is a sketch of how we would like the future circular economy to look like, with carbon removal on the end solution for residual waste that we cannot recycle. And this has been introduced quite thoroughly today. So I will focus on the last step of this waste hierarchy and the fact that we need to keep the raw materials in the cycle, and we need to stop sending waste to landfills, which is the greatest methane emission source and the greatest climate contributor to climate warming from waste handling. And I would like to address a couple of the statements from Jannicke actually on this slide, because and I would like to emphasize that emissions monitoring is not limited from waste to energy. At our plant, we have continuous monitoring and very strict emissions limits. And we've also, in Norway, there has been conducted several soil studies as well on the proximity of the waste to energy plants, which proves that there is no impact on the local emissions and on contaminants of the soil. So I really don't recognize the statements from Jannicke on that matter. I would also like to see the studies that are actually showing that landfills is a better option for residual waste, because that is quite the opposite of all the studies and the facts that I've seen, where landfills is the main problem for waste handling and the fact and the issue that we really need to address. And third, I think it's also worth discussing the issues regarding how to utilize the biofraction from mechanically sorted waste and the biofraction, because when it's mechanically sorted, the issue and the problem is to find use for this biofraction, because it's usually much more contaminated, much more heavy metals than with source sorting. So this is not a quick fix either with the MRBT. And fourth, I think it's also, and this was mentioned from the video just before this session, that one of the main issues that we're not discussing in this section is all the waste that is exported for other countries to solve the problems, which means that we don't have enough or too much waste to energy capacity. We have far too little to handle our own waste when we need to close down landfills. So adding this last step on the waste to energy plants means that we're not only reducing the emissions from fossil CO2, especially from the plastics, which is a problematic fraction to utilize and to recycle as well, and we need to work on that as well, has been mentioned. But we can also contribute to remove the biogenic CO2, which will be, as I mentioned, important to reach the climate goals. Very briefly on the last slide, I will give you a status of the project and the financing. Our project is fully matured through 2015 to 2020, and the Longship project reached the final investment decision in the Norwegian Parliament, and the state decided to fully support the transport and storage part of the project, which is called Northern Lights. What regards our project, we received conditional support, about 50% of what we need, CAPEX support of 200 million euros, and OPEX support of about 100 million, split over 10 years of operation. And that's why we have applied to the Innovation Fund for some of the remaining funding. Our project has a few very strong advantages. The most important is that we are fully matured. We are shovel ready as soon as we have the financing in place, which we hope to have at the end of 2021. We will start right away. We are partly funded from the Norwegian state, in addition to the fact that the transport and storage part of the project is fully funded and already underway. Also, a large BECCS potential is crucial for this project to demonstrate CCS on waste to energy and be a pioneer on climate positive waste handling. This will be replicable to a lot of the other waste to energy plants in Europe. And if everything goes according to plan, we will have the project and the carbon capture plant up in operation at the end of 2025. Thank you.
Thank you both for your presentations, and Jannicke, it's amazing to see the practical implications after we've seen quite a lot of the theoretical. I would like to come back to you online. Could you just go through what are the benefits and what are the disadvantages of using this type of carbon capture and storage technology on waste to energy plants?
Well, I think the advantages are very clear. We are dealing with the CO2 emissions from this end-of-line solution for waste, which means that we're dealing both with the fossil emissions that we are counting on emission statistics, but that we're also actually contributing to carbon removal, which will in its turn will give room for dealing with the other emissions that are harder to reduce in the short term. So waste to energy can contribute to removing large amounts of CO2 from the atmosphere.
Some disadvantages?
Well, I don't really see any disadvantages because this is an important technology. It's a very effective climate measure. It's very important for cities to address their large emission points dealing with their waste from the cities. And as I mentioned, also the carbon removal part. Of course, the disadvantage, if you could call it that, is that technology is still costly and it takes a lot of space. But that's because this is early in the development. We need to see a volume of these plants to learn from these first demonstration projects and to develop the technology, reduce the footprint of these plants, to improve the energy efficiency and so on, and to have the same development as other early technology providers to reduce costs and hopefully more and more integrate it into and combine it with flue gas cleaning.
The same questions to you. What do you see as the benefits and what do you see as the disadvantages of this technology?
I take it's in the context of waste to energy,
Yes.
right? So benefits, obviously, there is a pressing need to decrease the emissions to the amount possible. And we've heard a lot already today in different presentations that there's also the potential for carbon removal when it comes to waste to energy. That, of course, depends how much can be achieved will depend on how much biogenic versus fossil waste specific waste to energy plant actually burns. And that's not always the same. It can be quite different among different countries and different plants. But yes, we need to drive down those emissions, and carbon capture and storage is clearly a solution to do that. Now, the challenge is that we need the transportation and storage network, and it's the same problem for the other industrial emitters in Europe. It's kind of a chicken and an egg problem. You would want to have a network in place so that you can make the decision to start capturing from your plants, but then you cannot really have a network in place unless there is CO2 being captured that you can then use that network to transport and store. And what we really, really need on the European level is to have the plan to have such network in place. Many stakeholders have been asking for European CCS strategy. I think that would be a good place, for example, where this kind of plan could be laid out, because if you look at how CCS is developing and the projects are developing in Europe, they're developing in clusters where industry is present. And in some cases, there are waste to energy plants around, and you can then capture CO2 from all these different sources and use the common transportation and storage network. That really makes it a lot cheaper compared to, let's say, 10 or more years ago, when all the CCS applications that were planned were for one plant to have their own transportation and storage built out, which would make it much more expensive. So we would have this opportunity, but it's currently we don't have that plan yet, and that's a problem, and that makes it difficult.
So it's definitely a developing technology. Coming back to you online, you've mentioned it's kind of scalable. How many waste to energy plants could we see this type of technology on, and what is the timeline and the cost for that?
Well, I think in Europe in total, we see there are more than 500 waste to energy plants. Of course, there are different sizes and different locations, as Eve has also touched upon, on these plants. But a lot of them will have to and will need to look into CCS as a measure to reduce emissions from their operations. In Norway, we see that all the larger waste to energy plants have now started separate studies on CCUS. So I think this is a development that it's coming. It's going to be an important technology for the waste to energy sector to reduce the climate emissions from this process. But as Eve has also been clear on, we need to find solutions for the transport of CO2.
Be the type of cost for that level of scaling up?
Could you repeat the question, please?
What is the cost for that amount of scaling up?
Well, I would say that if we were to solely cover the cost of CCS by, for example, ETS price today, we would need to see a price of about 150 euros. But this is the early demonstration projects. So the cost will come down, and I'm sure we will also see the cost of emitting CO2 will have to rise. But for now, we are dependent on some sort of external funding, government funding, in addition to this, to the price of emitting CO2. And in the future, I think we will, actually in the very near future, I think we will see the bio content and the carbon removal market developing to be an important revenue stream for these projects. We see it today, large corporations are stating that they will go net zero, which also with historic emissions, which means that they will need to buy so-called CORCs, carbon removal certificates. And we see the prices already rising quite substantially on these private initiatives, market platforms. We know that the EU will come with a proposal for addressing these carbon removal certificates next year already. So this is definitely a market that will develop, and I think it will develop fast, and it will be an important contributor to develop these projects economically.
And Eve, coming back to you for a second, we've heard some environmental concerns about waste-to-energy plants over the course of today's event. Is waste-to-energy and carbon capture and storage enough to tackle that, or do you need more than carbon capture and storage to be able to maybe mitigate some of those other concerns?
Well, I have to be honest, I came here to talk about the carbon capture and storage part of things. But I think the biggest problem is the emissions and the need to reduce them, especially if you talk about in the context of the climate goals. So it does tackle the big part of it. And I think we have other regulation in place to tackle other elements of possible negative effects that waste energy can have. So yes, I would say definitely. I haven't heard of another obvious already existing solution that you could apply on waste energy plants to bring its emissions very close to zero, or in some cases even to negative. So we definitely have to work towards it.
And Jannicke, I know you had some criticisms of some previous people and what they had said, so I want to come to you on this question. But I also want to bring up something which Eve mentioned earlier about a carbon capture storage plan, something from the Commission, maybe a carbon capture strategy from the Commission. Do you think that would be helpful for this type of innovation?
Definitely. I think we will need this kind of framework and legislation to lift these projects. Absolutely. And if I may come back to the question that you asked Eve as well, and that I commented on earlier, I think this is exactly the important point to make, is that I don't recognize that statement at all. In Norway, and I know it's the same in Scandinavia, and I believe there are very strict emissions limits in Europe in general. For these plants, very clear and very low emissions limits to local emissions, and we have continuous monitoring of the flue gas. And as I mentioned, we've also done, or the Norwegian government, the Norwegian authorities have done several soil studies as well, which has proven that there are no increased levels of local contamination to the local soil. So I really don't think this is an issue. And what we need to address now is better source sorting and better utilization of the resources that we should keep in the cycle, and then to add carbon capture and storage to deal with the climate emissions from this end-of-line solution.
And staying with you online, we've heard about the efforts to fund this from both the EU and from the national government. What more do you need from the EU and national states in order to help support this technology and grow it?
Well, I think a very important step will be when we see next year the suggested framework for carbon removal and the bio share of the carbon capture part. So that will be an important step to establish markets and marketplaces for these carbon removal certificates, and to find future revenue streams. And then we've also mentioned the transport solutions for the CO2, which will be important to connect these emission points to established transport and storage solutions, such as Northern Lights, which is an open-end storage reservoir for other emission points to connect to as well.
Thank you. And we're beginning to round up this session. So if I could ask you both for your takeaways from this event. Eve, let's start with you. What are your key takeaways from this?
I'd say that for waste energy, carbon capture and storage is definitely a solution, and we need to work towards deploying it widely in Europe where it's possible. To make it happen, we do need a decent carbon price to cover waste to energy and carbon capture and storage, which currently we don't have. So, but we, as I said, we have options where it could be included. So I hope there will be serious discussions around it. And I mean, we have to bear in mind that it might not be feasible in every single, especially very small plants, and we'll need to think then how to tackle those emissions as well. So it is a solution. It might not be a solution for every single plant, but it can make a major difference in this sector and driving down the emissions and potentially generating carbon removal.
And Jannicke, coming to you online, what are your takeaways from today's event?
Well, to build on Eve's excellent bullet points, I would say that yes, CCS for waste to energy will be an important technology to deal with the climate emissions in the future. For smaller emission points, I think also CCU might be a contributor to find a way to utilize these smaller amounts of CO2 more locally. And second, as I have mentioned several times, the establishing of framework and legislation for carbon removal and the BECCS part of this projects will be important to find future revenue streams in addition to the carbon price of the fossil emissions. And third and last, I think this is also an important technology and an important way for cities to reduce their emissions, to reduce emissions from the large emission points of the waste handling structure in cities, and to establish sustainable waste handling.
Brilliant. Thank you so much, both of you, for joining us. Up next, we have our final debate, our panel discussion